Okay, so we left off with convex. So again, convex is no line that contains a side of the polygon also contains a point in the interior of the polygon. Okay, what that means is if I have this shape, if I have, again, like this hexagon looking shape, and if I were to extend all of these sides are never going to cut through the middle of that hexagon. It's never going to pass through the shape itself. So if I picked any point on these extended side lengths, no matter what, it's never going to fall in this shape there. Concave is the opposite of that. So concave is a line that contains a side of the polygon, also contains a point in the interior of the polygon. So this time, if I had some shape, something like this, I don't know, sideways V. If I were to extend to this side, that's fine. I never cut through the middle or even these outside sides over here. But if I started extending this side here, there's now a point that cuts through the middle. So think about concave. It's almost caving in on itself. You can draw it, and there's a point that'll end up falling inside if you extended one of your side lengths. Okay, so that's concave and convex. So if we skip to our next page, we have a couple shapes here. I know that B and C didn't end up drawing down or printing out, so just make sure you draw them. B, again, we've already talked about it. This is going to just be a hexagon. Okay, do your best with that. And then C would look something like this. Okay, so it says tell whether the figure is a polygon and whether it is convex or concave. So A would not end up being a polygon because this side here is cutting right through the middle. So individually, you have this trapezoid on the top and this trapezoid on the bottom. Those are polygons. Or even if I were to redraw it like this, that would be a polygon. But I can't have that side that cuts through the middle because we now have a side that intersects 4 different sides. So they can only intersect 2. So no, A is not a polygon. B, my hexagon here, yep, that is a polygon. And we had already talked about if we extend all the sides and things like that, we're never going to have that point that cuts through the middle. So this is a convex polygon. Okay. We also talked on the previous page that we can't have any curves to our shapes here. So C with that curve is not going to be a polygon. Okay, and D follows all of our rules. All the side lengths intersect another side or intersect 2 other sides at the endpoints. In this case, so yes, it is a polygon, but if I draw those extensions of the side lengths, we end up with a point that would cut through the middle. So yes, D is a polygon, but it is a concave polygon. Okay, so now we want to talk about what types of polygons there are. So it is all classified, they're all named based off of how many side lengths there are. So a 3-sided polygon, we know that's a triangle. Okay. A lot of these names come from these prefixes. So tri means 3. Those all come from like the Greek alphabet, Greek language and everything. So tri means 3. That's a triangle. A 4-sided figure, we know that could be a square, a rectangle, a rhombus, a kite, but the overall official name for that is a quadrilateral. Right? If you think about like dirt bikes and everything, you can talk about riding a quad, right? A 4-wheeler. So quad means 4. And then we have a 5-sided figure. If you think about Washington, D.C., that's the Pentagon. It's a 5-sided building. The penta, that means 5. 6-sided, we talked about, that's a hexagon. So that hex means 6. We probably, if we have heard of it, that's pretty good, but we probably haven't heard of a 7-sided figure. A 7-sided